You are welcome to Modern Startup. In a few minutes, we'll be discussing the concept of sample space. And first of all, we're going to be looking at the definition before we look at the practicality that is attached to it. Now, by definition, what do we refer to as a sample space? By definition, what do we refer to as what? A sample space. Now, a sample space can simply be defined as a set of all exclusive cases of random experiment. What I mean by that is that it's actually the set of all possible outcome of an experiment. That is what a sample space does. For instance, if I will come down to a layman definition, I will have said it's the possible number of choices you can make per decision. That is what you can refer to as a sample space. So it gives you all your choices, all of the possible choices, or all of the possible outcomes that can happen as a result of conducting a particular experiment. For instance, when I toss a coin, either it shows a head or it shows a tail. So these are the two components or the two parts, the two sides of a coin. If they happen to be three, then it would have been three sides perhaps, but we know, for instance, that coin has just basically two parts, which is the head and the tail. So I come again by the definition. I said that it's actually the set of all possible outcome of a random experiment. That's a sample space, and in most cases we denote it by X. Otherwise you could use another letter, but in most cases we make use of S as its denotation. So, and every entity or every outcome of this sample space are referred to as sample point. Sample point. So I could just, if I use my sample space to be capital S, then I could use my sample point to be small letter s and let it be S1, S2, S2, all the way down to, let us say, Sn. This could be a sample point. Or better, you can say that your S is equals to what? Your Si. Si. Such that what? Such that your I range from 1 all the way down to n. That in a way I've been discussing, that means I'm just defining a finite sample space, because we could as well have an infinite sample space. So if it was infinite sample space, the boundaries or the range of I will have been what? Will have been infinity of that nature. So that is that for a sample space. When it tried to look at the set of possible outcomes of an event, this is what we're likely to come about. Now, there is also one thing we need to look at before we go on. But before then, I feel a need. I feel a need for me to actually make us take one or two examples about sample space. For instance, tossing a coin. When I toss a coin, what is my all my sample space look like? So I have tossing a coin is either I have a head or a tail. But if I throw a die, what am I going to be having? A die is that I have 1, I have 2, I have 3, I have 4, I have 5, or I have 6 as my sample point. If I had tossed an octa die or octahedron, I'm going to be having, because the octahedron has about 8 sample points. So I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7, and obviously I have 8. But if I was to write it in a more composed or more mathematical form, it should have just been that S is equals to, say that what? Say that S what? Si. Are you with me? Si in a way, and you just let your Si, all of it is edged in between what? 1 all the way down to what? To 8. In that way. So I'm going to be having that as my possible sample space. In other words, it can also be composite in nature. What if I toss a coin and a die all together? What will be my possible outcome? Now, this can be the sample points can be gotten in list form, in tabular form, or in a tree diagram. What do I mean to say? In that case, I can get my sample space to be either in what? In list form, in tabular form, or what? Or with a tree diagram. Now I'm going to try to assess these three forms of getting a sample space of tossing a coin and a die simultaneously. So when I do that, what am I likely to have? Then if I'm going to use my list form, my possible outcome is going to be my S, that is head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, and tail what? Tail 6. That is if I was to what? If I have to use my list form, and it's actually, I think it's simplified. Meanwhile, how do I know the number that the cardinality of my sample space? I'm going to be multiplying the number of side of my coin and the number of side of the die. Number of side is 2, number of this is 6. Eventually, it's going to be what? N of C times N of D, which will eventually give me what? 12. That will be my sample point. So if I was to make use of my tabular diagram, it's going to be of this form, such that I have my head, I have the tail, I have it to be my sample point, I have 1, I have 2, I have 3, I have 4, I have 5, and also I have what? I have 6. So I have head 1, I have head 2, I have head 2, I have head 2, I have head 3, I have head 4, I have head 5, I have head 6, I have tail 1, I have tail 2, I have tail 3, I have tail 4, I have tail 5, and I have tail 6. So I'm going to be having my sample, and I think this is more easier, and you can use it at any point. It's more easier actually. But if I was to make use of my tree diagram, it's also more beautiful. All I just need to do is to say that what? Okay, my first tree is to be the tree of my sample point for the die. 1, 2, 3, 4, 5, and 6, which each of the branching have head and tail. Each of the branch have head and tail. Each has 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 head and what? And the tail. On that note, I'll be having my what? Head 1, tail 1, head 2, tail 2, head 3, tail 3, head 4, tail 4, head 5, tail 5, head 6, and tail 6. That will be my what? My sample space with respect to what? With a tree diagram. If I'm doing that, and that will give my sample space. So these are possible way of getting that done. Get that done. So in a way, the sample space of a particular experiment can be likened to set of like a power set. And you know that your power set by definition is a calligraphic P of a given set A, such that your formula is 2 raised to power the cardinality of that set A. Do you understand? So that if I was to toss a coin twice, then I know that the sample space outcome will be 4. If I was to toss it thrice, it's going to be 2 raised to power 3, and that is going to be 8. If I was to toss it 4 times, it's going to be 2 raised to power 4, that will be 32 outcomes. That is the pattern for which it follows. So if I was to toss my coin also, my die rather twice, you know that I can use my tabular form easily, just like I can use my list. 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have all the way down to 6 as well. 1, 2, 3, 4, 5, and what? And 6 as well. Then I'm going to be what? Merging 1, 1, 1, 2, all the way down to 3, 2, 4, 3, and all that is going to give me what? My sample space for tossing 2 dice. Do you understand? So, but there is one other factor or one other entity we need to describe as well, and it is referred to as what? As event. What is an event? What makes it different from a sample space? Now, basically, an event, of all the possible outcome of sample space of a random experiment, some outcomes specify a specified description, and those outcomes we refer to them as events. events, and that's because they can contain one or more what sample points in a sample space, basically. So, for example, now if I was to give an example, if I was to toss, for instance, I have if I was to toss a coin thrice. If I was to toss a coin thrice, and I'm going to be having head. You can try to either tabular forms or the tree form. You get the same thing. I want to mix up my list form now. I could have head tail. I could have head tail. I could have head tail head. I could have head tail tail. I could have tail head head. I could have tail head tail. I could have tail tail head, and eventually tail tail tail. Then I could a scenario can come up where you are expected to specify event where we just have two heads showing up, and in that case, okay, that will be an event, and it's going to be extracted from what, from my sample space. So just I will pick out sample points that has two heads. That is head tail is one, head tail head is one, tail head is one, and that is all that I have. That means the set of possible outcomes having just two heads showing up. So this could be event one, depending if that is depends if I'm going to have more than one event of, okay, when head does not show up at all, that means tail. That's another event entirely. So in other words, we can easily convert a theory saying that then we know that our sample, our event space EI is a subset of what our sample space, so that your I is actually in the realm of what, of natural number. I know your natural number is accounting numbers, basically. So that is that for that, and it works on and on and on in that same way. So I would like to have your questions in the comment box in case you have any, and then but please do ensure that you subscribe and that you like this video, and also try to drop a comment, share with family and friends as well. Thank you for being a part of this.